Supplemental math videos from Circle Christian School.
Solving rad radicals and the x equals. All the steps are there. You've been doing it since Algebra 1. You just need to get the x all by itself. The difference here is that the x has a bit of a condition to it. It's underneath a radical. So what you have to do is get the radical all by itself. And sometimes you have to get two radicals all by themselves, and you may have to do some foiling inside there. The deal here is you've got to remember to use those rainbows so you can see where the radical's going. All right, let's try a few of these here like we did in class. We got to get the radical by itself, which means we got to do the inverse thing. We're going to square the radical. If you square one side, of course, you have to square the other side. And so the result is that we get x equals 9. Throw it back into the original equation, you know it's true. Sometimes the radical is a little bit bigger. It has some things being added to it. Don't sweat it. Again, you're just going to square everything. Anytime you square a radical, whatever's inside comes outside. Makes it nice and handy. And now you have a regular algebraic problem to deal with. Sometimes we have some things hanging around the radical. And knowing that we still have to get the radical by itself, it may mean that we have to do a little bit of isolating before we get there. So we're going to add the 8 here and add the 8 here. And that's going to give us the 20 with the 2 out in front of the radical. And again, we're just going to get the radical by itself. So we have it's isolating the condition here. It's kind of that step 4 thing. And we're going to get the radical now, who's all by itself, equaling the constant number here. And now we can just do the little squarey thing. There's a square. Here's a square. I got a square. You got a square. Ha ha ha. We both got squares. And we get x plus 4 equals 100. And you can do it from here. The more challenging ones are when you have radical equals a radical. And so what we're going to do is if you square one side again, you're going to square the other side. And beauty is made because whatever's inside the radical is going to come out. And again, we're back to just having a regular algebraic problem, solve for x. Sometimes we have some things attached to the radical that's not inside the radical. And you'll notice over here on the right-hand side, we have a whole radical. The left-hand side, we've got a radical and then something being added to the radical. So what I'm going to do is actually square the radical here on the right-hand side. But that means I'm going to have to switch this into being a binomial now, because it's a radical binomial. That's what it is. And we're going to have to square it. All right, what this really means is that we have the square root of x plus 6 times the square root of x plus the 6 equals the radical squared here on the right side, which means it's just going to come out. Now, he looks nice. The other guy looks a little bit challenging. And so what we're going to have to do is that little FOIL thing. And I suggest using the arrows in the circle just so you can see where you're going. We have a square root x times a square root x, or a radical times itself. That's going to give us x. Then the x times the positive 6. So we get a positive 6 square root x. And then we're going to do the next one here and FOIL it out. Hoping I have enough room here. And so we have, again, the 6 plus, the plus 6 square root x. A number multiplied to the radical just goes out front. And then the 6 times the 6 is a positive 36. So now what we have as a result is an x plus a 12 square root x, that's adding your radicals, plus the 36 equals the 2x plus the 1. And we're going to minus the x and minus the 36 over on the other side. And forgive me while I actually just kind of move upwards here, but the result is the same. So we get the 12 from the square root x equals the 2x minus the x plus the 1 minus the 36. I just had these guys jump the fence here. So now we have a 12 square root x equals, combining my like terms here, an x, and combining these like terms, a negative 35. So now you have a couple options here that if you wanted to, you could just square both sides or divide by the 12. Dividing everybody by the 12 kind of gives us these freaky little fraction things, and I know you don't quite like that. So I am actually going to opt for just squaring both sides here. And this is going to give me 144 and an x, because that's the radical squared. 12 squared is 144. Square root x times square root x is x. And now we have that binomial square here, so it's the same thing as x minus the 35 times x minus the 35. Generally, when you see radicals on both sides here, it means some sort of quadratic thing was happening to begin with. And so now we have 144x. And doing the rainbow thing, boiling out your double bubble here is going to give you x squared minus 70x plus 35 times 35 is 1225. Yes, I did stop and use my calculator. Okay, and now what are we going to do? It turns into this really ugly quadratic thing. But that's okay. I just have to realize that I made this up. I didn't exactly take it out of the book, but it ends up being quadratic. I don't believe you have any in your book that are quite this complicated, but since I have something quadratic, it just means that I'll default to the quadratic formula, which is actually what you're going to get Monday, Tuesday anyway. So there's some sort of quadratic thing that's happening here. All right, let's take a look at the last one. And my emphasis on the last one is really to just show you what happens when you have to take a rather larger radical binomial and square it. And so what we actually have here is the radical times the radical. And again, it's really helpful to make sure you use those rainbows. And just following the rainbow here, you'll see what you have is a radical times the same radical, so it's just going to come out. So we have the x plus 3. And now I'm going to take that radical, that large radical, and times it to the 4. And it's positive, so it's just 4 times the really large radical there, the x plus 3. And now we're going to do the other part of the foiling, the positive 4 to the radical, which is the same thing that we just had, a positive 4, square root x plus the 3. And then we have the 4 times the positive 4, which is a positive 16. Which ends up with a x, and okay, so there's my x, And we have two radicals here, so plus the 4 here and the 4, so that's a plus 8 with the cute little radical here. And then we've got the 3 and the 16, which is a positive 19. And all that's going to equal whatever you had over here on the other side. And the whole thing, you'll notice that once you get to it, is that you're going to end up having to get that radical all by itself. All right, if you have any questions, just let me know. I'll be happy to help you. Have an awesome weekend.